Hello everyone. In this lecture, we are going to see the physical and logical design of IoT. So, firstly, we will see the physical design of IoT. Yes, actually, this physical design of IoT consists of three parts. The first part is things in IoT, which we have already discussed in the previous lecture. Anyhow, I will repeat. And coming to the second part, yes, second part is the generic block diagram. This is the generic block diagram, also known as the connection diagram using physical design for IoT. And nextly, we will see the IoT protocols. Up, up to here, these three parts are belongs to physical design. Once physical design of IoT is over, then we will discuss about logical design. Yes, as I told in the previous lecture, in IoT, nothing but Internet of Things. The things are nothing but the IoT devices, nothing but the smart devices which automatically work without the manpower, nothing but without the human interference. Based on the surroundings itself, the device works and it sends data to our respective end device. And now we are going to see about the devices. So those devices are nothing but, here you can see wearable devices, nothing but smartwatches. As we all discussed, just let me show you. Yes, here we have discussed about various applications, right? So in those applications, in what devices you are using, those are only here known as the devices with in part of physical designing IoT. Wearable devices are nothing but smartwatches, fitness trackers, BP checking machine and all, pulse rate and all it will calculate, right? So based on some sensors it works. That's why here we have mentioned a thing as devices and sensors. In next slide, we are going to have about sensors. But if you are interested to know more about the sensors, in description of this video, you can find our video link about the classifications of sensors and their usage. Yes, now coming to second type, smart home devices for smart lighting, automated AC, automated door locking system and all such devices comes under this part. And in industry, temperature monitoring and for smoke detection devices and all. And one more thing is logistics tracking using the GPS module. And next, smart appliances, all you can include here. Yes, connected vehicles, we use two things. One is GPS tracking and one more is diagnostics. Diagnostics, as I mentioned in the previous lecture, it completely analyzes your vehicle, and if any failure or any damage is present in the vehicle, it will indicate you uh, based on how much typical is the problem to your vehicle and how can you manage it, and regarding those all you can see in the remote diagnostics for a vehicle. Now coming to next slide. Yes, these are some of the sensors, and if you want to know more about the sensors, you can see in the description of video. I have attached one of the link. Yes, temperature sensors in digital we are having DHT11, DHT22. Here DHT is nothing but digital humidity and temperature sensor. That's humidity sensor you can mention for both. You can mention DHT11 and DHT22. Both are correct. Next, proximity sensors are nothing but they detect the presence or absence of objects within a certain range. Nothing but example for it is ultrasonic sensor. For calculating the distance of an object from sensor, how far it is, we use that sensor. Coming to motion sensors, we are having infrared radiation sensor and passive infrared radiation sensors, nothing but IR and PIR sensors. For light sensor, we are having one of the analog sensor, light dependent resistor, we'll call it as LDR sensor. And still we are having pressure sensors, accelerometers and GPS all, yeah. GPS module sensor I have mentioned, right? that actual full expansion is global positioning system. So it is used to get the GPS location for shipment tracking and all. We will use it. This is the first part of the physical design. Nothing but about things, and in things, how those things are used is based on devices and sensors. This is the first part of physical design. Now let us go to second part of physical design only. Yeah, this is the general block diagram of IoT devices. Let me show you next slide because diagram will be very much clear. Yes, it consists of totally 7 parts. First part is nothing but connectivity. Yeah, connectivity, by the name itself, you can understand that it establishes the connection. But from where to where it establishes? From client to server, it establishes the connection. Based on, yeah, it uses USB host, nothing but our USB connection. And one more is Ethernet cable, nothing but for our Wi-Fi we will have cables, right? Some yellow color, blue color, some fat wise. Those are known as Ethernet cables actually. So such network is called wide connection. Remember that one, wide connection or wide internet connection means it is Ethernet. Wireless means then we will call it as Wi-Fi or Bluetooth. Yes. Once the connection is done, next process takes place is processor will take place and processing will be done where in CPU as it stands for central processing unit. Yeah. If you are going to work more with graphics, then what you are going to use GPU. GPU stands for graphical processing unit. I hope you all know about CPU and GPU. Now coming to next step, audio or video interfaces. Here it uses HDMI. HDMI is nothing but if you are using a desktop, nothing but computer, backside there will be a cable which is connected to the CPU. Actually, every functionality is done by your CPU. But how can you understand? For simply we can say it as like interfacing. Means you can watch or you can listen. Everything can be done through monitor. So that connection will connect using those HDMI cables. And for that, for audio, one we are having 3.5 audio, and for video we are having RCA. Those are used to record audios and videos in the system. Now coming to, yeah, before going to this IO interfaces, once you come here, memory interfaces. Actually, in memory interfaces, you will use NAND or NOR, or either DDRs you will use. These memory interfaces actually control these IO interfaces. And I have already explained you about this GPU. Now coming to storage interfaces. By the name itself you can understand it will store the data. Whose data it will store? This input and output interfaces, nothing but the data of sensors and actuators are stored using the storage interfaces. So how can you interface for sensors and actuators are input output interfaces for sensors and actuators. These act as a interface for sensors and actuators, nothing but how those are going to work. Sensors, as you know, sensors will use it to make your device smart. But how sensors are operated are by making use of these actuators. But how can you all, how can we understand the functionalities by making use of these IO interfaces? Now, for that examples are UART, SPI, I2C and CAN. If you are aware of computer networks, then you can understand these things easily. So now next coming to, yes, this is the third part of physical design. Nothing but IoT protocols. If you are aware of in operating system, if you are aware of TCP IP model, then it will be very much easy to understand. If you are not aware, also not an issue. These are very simple topics. Yeah, these are the 4 layers in IoT protocols: link layer, network layer, transport layer, and application layer. Actually, I am not going to explain the complete theory because notes link is attached in the description. In simple terms, I will explain each and every topic so that you can study on your own later. Yes, from bottom we will study the layers and one protocol we are going to explore. Yes, firstly Ethernet. Just now I have told the wide internet connection is called internet and wireless internet connection is called as Wi-Fi. I hope these two are clear for you. Now coming to WiMAX. WiMAX is nothing but Wi-Fi with MAN. Nothing but if you are aware of computer networks, there you can study PAN, MAN, CAN, WAN and all, right? What what does MAN stands for? MAN is nothing but metropolitan area network. Nothing but it covers the entire city, that area network. So such Wi-Fi network is in simple terms here it is defined as WiMAX. Next coming to LRW PAN. PAN. According to computer networks, what does PAN stands for? Personal Area Network. And here coming to 2G, 3G, yeah. Now 4G, 5G are also coming, right? Those all are belongs to cellular data. Now just let me show you the next slide. Yes, you can see same things are discussed here. Yes, this man, as I told, it covers the entire city, metropolitan city. So it is very broadband and wireless access, point to multi-point. Yes, that's the advantage. Now coming to this PAN, by the name itself, it is personal area network. Means it will be very low cost, low speed and very much near communication is only possible. For PAN, it will be within 2 kilometers to 5 kilometers range, I guess. Yes. Now next coming to 2G, 3G, 4G, it is completely related to mobile communication. This is the link layer. Then what is the next layer? Network layer. IPv4, IPv6, 6LoW, WPAN. Yes, IPv4 is nothing but Internet Protocol version 4, version 6, and this is 6 low wide range personal area network. IPv4 is actually 32-bit and IPv4, if you want to get security, you need to use separately the security protocols. Whereas IPv6 is the updated version of IPv4. IPv6 is 32 means yes. IPv6 is 128-bit and by default IPv6 automatically provides security. That is the most advantage of using IPv6. And next 6LoW WPAN. Yes, it is a low power wireless personal area network. Yes, you can also call it as Wi-Fi personal area network because wireless itself indicates that it is Wi-Fi. If it is mentioned as wide, then it belongs to Ethernet. So this protocol allows for the smallest devices because low power we are saying. So that's the reason it supports to very much small devices with limited range of communication. Yes, after network layer, next layer is transport layer. There are only two protocols, TCP and UDP. TCP stands for Transmission Control Protocol. UDP stands for User Datagram Protocol. And this TCP is completely based on our transmission control and it is user datagram based protocol. Yes, this TCP provides so much security and it transfers the message. Actually, the message which we send from sender to receiver, it will divide into chunks, nothing but packets. Those packets are transferred from this TCP from one layer of the network layer security to another layer. That's the advantage of TCP. Now coming to UDP, it is the connection-less protocol and this protocol is not required to establish the connection to transfer data. It must and should require the network establishment. Nothing but connection must and should be established for TCP. For UDP, there are no such conditions. Yes. Till now, what we have seen link layer, network layer, transport layer. Coming to the last layer, nothing but the top layer, application layer. Totally, there are 7 protocols. One by one, we are going to see with the diagrams. Yes. In application layer protocol, we are going to use those 7 protocols. The first protocol is HTTP. Each and everyone are aware of HTTP and HTTPS. Nothing but this is a request and response, and you know that HTTPS is the secure version and all. But in HTTP, this computer you can see, right? This is client and this is server. Client is requesting, server is responding. Yeah, for HTTP, what are the methods you are going to use are put, post, get, delete. It is similar to our CRUD operations in database management and all. This is how HTTP works. Then next protocol comes here is WebSocket protocol. Yes, here by seeing diagram itself, you can understand that it is a two-way communication between the client and the server. Yeah, host or server is one and the same. Here you can see, right, two-way communication. Hello server, hello client. This is how WebSocket works, and it is commonly used in web browsers. Here you can see one of the example also. Yes, now coming to next protocol. MQTT, it is one of the most important protocol in case of IoT, and we are going to work with the hardware components by making use of MQTT instead of HTTP. Here, MQTT is a machine-to-machine connectivity protocol. Yes, how we are having the methods in HTTP like push, post, get, delete and all. Here in MQTT also we are having uh, two methods. One is the publish and one more is subscribe. Method names are publish and subscribe. And here since we are working with devices, those are known as publisher and one more is subscriber. And this MQTT process in middle there will be MQTT broker. Publisher publishes the message to MQTT broker and MQTT broker will nothing but these subscribers, nothing but these clients will be subscribed to MQTT broker. So from MQTT broker they get the information. And one more thing with this MQTT process is, yes, subscribers are not aware of this publisher. Means well, means even they can be aware of, but there is no compulsory rule that this subscriber should know the publisher. There is no such rule. And this MQTT broker, by the name itself, you can understand, it acts as a middleware. This is how MQTT protocol works. Coming to next protocol is CoAP, Constrained Application Protocol. It is a specialized international application protocol and it uses CoAP communication, nothing but Constrained Application Protocol communication. And one more is HTTP communication. Here REST means you know that representation, stateless transfer protocol and all. Since this is in link with HTTP, this complete inside one we will call it as CoAP environment, and this is known as the CoAP server and this is known as just CoAP proxy. Since these both are stateless transfer, and here CoAP server will communicate in a two-way communication process with the respective clients. Here we don't call them as subscribers. Here we'll call them as clients. Remember that thing. Yes. Now coming to next protocol. Yes. XMPP. Here you can see name, right? Extensible Messaging and Presence Protocol. By name itself, you can understand that extensible markup language. It is nothing but it uses XML. It is communication protocol for message-oriented middleware based on XML. Yes, here there will be not a, yeah, still now what all protocols you have seen, there was only a single server. But here there can be two or more servers. Servers are connected in a two-way communication process, and each server will have their own respective clients, such that this client not only gets information from this server, even he can get information from this server too. That's the advantage of using XML. Sorry, this XMPP protocol. Yes. Next protocol is DDS, nothing but data distribution service. Yes, here you have in MQTT you have seen that publisher publishes to MQTT, and from MQTT subscribers gets information. Nothing but MQTT broker will send the information to subscriber. But in this case, it is the subscriber part is completely different. Here, publisher will only publish. They will publish to global data space. That is nothing but here DDS, data distribution service. Subscribers should only access, and they themselves should get the information. But whereas in MQTT, that MQTT broker will send the information. But here subscribers themselves should access the information. Yes. Before logical design, yeah, this is the last protocol. With this, physical design of IoT will complete. Yes, advanced message queuing protocol. The AMQP protocol, yes, queuing, nothing but it makes usage of queues. Remember that one? There we have seen MQTT broker. Here AMQP broker we will call it as. Same here also it is somewhat similar to MQTT protocol only. Publisher publishes the message, and here exchange facility is provided, and Q1, Q2. Each consumer will be having their own queues. Here you can see subscribe to the queue, send a message, and here you can see consumer will request and it will send a message. Yeah, this is how AMQP protocol works. Advanced message queuing protocol. It uses queues. Nothing but first in, first out principle is followed here. Yes, with that, physical design is over. Once again, let me recall complete physical design. Oh, I came front. Just a second, let me go back. Yes, physical design of IoT. First part is about the things. Things, nothing but the smart devices. That's why we are discussing about devices and sensors. That is the first part of physical design. Second is generic block diagram. Third part is IoT protocols. With this, physical design of IoT is completed. Now coming to the logical design, it is very much simple and easy to understand. Yes, in logical design, it also consists of three parts. The first part is the functional blocks. Nothing but about the functionality. This is the diagram. Application, device, services, communication, security, management. By seeing the names itself, you can understand. Application means nothing but for what purpose it is being used and all. Device is nothing but about the smartness of device by making use of sensors and all. Management is nothing but how that application is being managed. That process is known as management. And what are the services that are provided by application, and how the data is secure such that by in during the communication the data from device is transferred to the end user. Nothing but for a smart home application, I have told that automated door locking security system, there the data is shared only to me. Not it can't be shared to some other XYZ person. Because if suppose it shares to me, then for first time I may catch the thief, but if my data is not being secured, some person can understand that yes, in my home such smart application is there, so he will try to break the server and all, and he may do hacking and all. So to avoid all such things, we maintain some protocols which we have discussed earlier. So that all comes under security. And communication is nothing but how it by making use of which technologies it sends, or we are also having communication models and communication APIs that are nothing but second and third part of logical design. Those all we are going to see. Yeah, this is what the first part of logical design is about. Same theory is mentioned here. Yes. Now coming to IoT communication models, there are totally four types of models. Yes. One by one we are going to see. First thing is request response communication model. By the name itself, you need to understand that request response is nothing but it is completely the HTTP. There we are in physical design, we have discussed with the name protocol. Here we are discussing with the name model. But the complete process is same. Client will request, server will respond, server will have resources. Nothing but it is similar to our HTTP. Here request and response are also in form of HTTP. Yes, this is request response communication model. Publish, subscribe. Broker, nothing but which protocol? MQTT. Don't treat it as other protocols. It is completely based on MQTT protocol. That's why we have mentioned as publish, subscribe. Here publisher will publish to broker, nothing but MQTT broker. And each yes, here some like topics it is divided, right? for for a particular block, these subscribers can only get the information, and for this block only these users can get information. If I want to explain with real time application, for a college website, if you take, one will be for faculty access and one will be for student access, right? If you will assume this as faculty, this from here this information will be only shared with faculty, but only this information is shared to students. Like that we can compare with real time examples. Next thing is push pull communication model. Yes, here you have seen queues, right? By seeing this queues itself, you can understand that here we are going to perform AMQP protocol technology. See here, there is nothing new. What all you have discussed in the name of protocols in physical design, here you are calling them as communication models and you are explaining. That's it. Here you can see publisher. He sends messages to queues. Nothing but here broker. There we will call it as broker. Here we will call it as only queues. And from these queues, yeah, which data is sent by publisher first, that first message will only go. For example, publisher sent hi, then hello. First hi is going to be delivered, then hello is going to be delivered. Since by the name queue itself, it will follow first in, first out principle. Similarly, for consumer too. This is how push-pull communication model works. Coming to next model, yeah, this is the new model, exclusive pair communication model. Here, there will be only client and server. Client will request for setup connection. If the client is an authorized or is a real client who belongs to access that particular data, for them server will accept their request and it will give as a response. So here, yes, remember that one. Once the communication is over, then we need to, yeah, client will say to close request. Yeah, connection close request will give to server, and server will also respond as the connection is closed. Yes, remember that one. These first two arrows and this last two arrows, these four will be fixed. And here there is a no, not mandatory that only just a single message can be asked to server. Yet this can be repeated infinite number of times. Remember again I am telling, connection establishment and connection closing can be done only once, whereas the connection communication can be done infinite times. Means he can message from, yeah, client can message to server infinite number of times, and based on the client's request, the server will respond back. This is what is exclusive pair communication model. With this communication models, nothing but second part of logical design is done. Now coming to the third part, it consists of communication APIs, and we are having only two types of communication APIs. Yes, one is the REST base, nothing but representational state transfer protocol, and one more thing is WebSocket based communication APIs. By seeing diagram itself, you can understand. Anyhow, I will explain again. Yes, coming to REST-based communication APIs, there will be HTTP client and HTTP server. How messages are sent by using these commands? Nothing but those are called as HTTP packet. And HTTP server is linked to resources. It is nothing but same HTTP communication model here in diagrammatic form. In deeply we are discussing. Yeah, HTTP client. Yes, client requests the server by making use of these HTTP packets, nothing but JSON, nothing but JavaScript object notation, and one more extensible markup language XML. Those are called as REST payload. But since this is completely based on HTTP, what are the HTTP methods or HTTP commands? Get, put, post, delete. So based on our request, that particular request is reaching server, and here firstly server will authorize whether this client is a authorized client or not. Like that it will verify. And RESTful web service. Yes. Once if this server knows that he is a authorized client, then it provides the RESTful web service. Nothing but server, yes, data is present in resources. This server will get the data from those resources, and you can see a two-way communication, one for requesting process and one more for responding back. So it is a two-way communication like structure. So from resources, it will again send data to the client to satisfy his request. This is how REST-based communication APIs work. Yes, this is the complete theory about statelessness and all. Yes, the second type is WebSocket based communication APIs. By seeing diagram itself, you can understand that it is similar to exclusive pair communication model, but it is actually right. Don't think it as wrong. Client server, but here you will mention the name with WebSocket protocol. Same request for connection, responding to accept the request. Yeah, here there we have seen that requesting. Yeah, message we call it as, but here we are calling it as data frame. That's the only difference. Bidirectional communication. Yes, there also it is a bidirectional communication. Starting, yes, that's the reason I told in middle we can communicate infinite times until the connection is closed between the client and server. This starting to and ending to are always same. This is for establishing the connection and this is for closing connection. And in middle we can communicate infinite number of times. Data frame as a request, data frame as response, data frame request, data frame response. This is the WebSocket communication APIs. Yes, with this completely we have covered the communication, nothing but the IoT models, physical and logical design. Once again, yes, physical design I have already repeated. Logical design consists of three parts. First part is about the functional blocks, nothing but what the functionalities are done. Second thing is about communication models. There are four communication models. And lastly, communication APIs. There are only two types of communication APIs. With this, the physical and logical design of IoT are completed. Here in last slide, you can see domain specific IoTs. That is nothing but the applications of IoT which we have seen earlier. In previous lecture, you can watch again if you are getting doubt and all. Yes, about these things only it is covered in domain specific. Yes, that's all with this. Physical and logical design of IoT are done. And in the next lecture, we are going to see about the Arduino Uno and its configurations. It is already discussed in the Arduino Uno playlist actually. So again, I am not going to take so much time because anyhow I'll add those videos even in this playlist. You can watch them, and the notes is attached in the description of video. If you are facing any doubts, you can drop in the comment section. Thank you.